If you've been watching my previous videos, then you'll already know that I undertake a lot of different types of projects, from the repair of vintage electronic equipment through valve equipment and up through modern digital electronics, microcontrollers, microprocessors, all manner of systems. And anyone that's done this for any length of time will know that one of the pieces of equipment that you can never have enough of are power supplies. So I have a whole range of power supplies, ranging from my most used supply, which is a Riden DP832, it's a triple output supply, through cheap and cheerful high current supplies, through to ultra precise supplies. This is actually a voltage current source monitor. This will go down to literally picoamps and up to over an amp in its range. So very capable, but I don't use it that often, but it's very useful when I need ultra precise voltages. This unit is one I got off eBay. It didn't work. It was originally 30 volts and I've modified it so it now gives out 42 volts at 10 amps. The Riden, I think there's plenty of information about these. They're two 30 volt outputs and one 5 volt output up to 3 amps. And then I have a whole range of other types of supplies. So these cheap Chinese supplies, I use these for isolated supplies, and these are all fine. But one type of supply I always struggle with when I need it is a high power supply, a high power precision supply. And what I normally end up doing if I need precision and high current is tying all the outputs of the Riden together. But that's a bit inconvenient, and it also means I can't use that for the rest of the project, and quite often I need quite a few different supplies for some projects. So this video is about a project I've been meaning to get onto for some time. Unfortunately, I've sat on it for so long that Dave over at EEV blog has kind of beat me to it, but I thought I'd complete this anyway, just for anyone that's interested. And what it is the construction of one of these supplies. It's an RD6006, so this is the actual supply unit, and I purchased this a while back. So I've got the supply unit. I also purchased the enclosure that comes with it, so a nice metal enclosure, and I also picked up a suitable switching supply. Now originally I was going to build this with a linear supply, so I've got some big toroidal transformers that I was going to use, and I may well build a second one using that, but this video I'm going to use the switching supply. So we'll unpack this, have a look at the various parts, and then see how to put it all together. And then in the second video in this series I'll go through some testing of it and we'll see how it performs. So I'll start with the main unit. I haven't unboxed this yet, so I thought I'd do it live on camera. So we'll see what we get in the box. Nothing useful there. Very nicely packed. I actually paid less than £100 for all the components for this, so cost wise extremely good. You could get 4 sets of these for what I paid for the Riden, and still have £100 left over. So what's in here is the main power controller, and I've bought a lot of Chinese, cheap Chinese pieces of equipment over the years, especially over the last 3 or 4 years, and they do vary a huge amount in terms of quality. This one does look to be extremely good. It's first sight, it does appear to be very nicely put together. Certainly in terms of its finish, it is one of the best I've seen in terms of very low cost Chinese pieces of equipment. How well it will work, I've got no idea, but certainly first signs are looking fairly promising. So what you get in the basic kit for this is the controller itself, and spare fuse, some connectors, that's a remote temperature sensor, and that's it. There's no instructions in here, but I believe you can download the instructions from their website. I also ordered the enclosure. So this quite surprised me. It's much better than I expected. It's obviously metal, and what surprised me the most was that it came with all manner of fixings. I wasn't actually expecting this to be supplied with the case, so we'll have a look to see what's in here. So we've got the power socket and the mains switch, fixings, fittings, washers. That looks like a remote temperature sensor board, so it looks like there may be a secondary internal temperature sensor to control the fan. So yes, there is a fan in here as well, so presumably these two work together, and there's a thermally controlled fan that sits inside. Power cables, mains cables, so quite a nice kit. Again, considering the price, is extremely reasonable. But of course, this does not include the actual power supply itself. This is just the controller. So I needed to get a supply. You can use pretty much any supply you want, so I opted for this one. The specification is 60 volt 10 amp. Now the spec for this device allows up to 70 volts to be put into it, and I think the output is from 0 to 60 volts, but there is of course some loss and a voltage drop in the control system, so you need a higher voltage going in than the maximum voltage you want out. The purpose of me building this was to have a high current, high voltage supply, so I wanted something that would go right up to 60 volts. So I got the 60 volt switching supply. Although the controller is only 360 watts, so it's 60 volts up to 6 amps, I've gone up to a 600 watt supply, so that's 10 amps at 60 volts, because if you read the spec for these, you're not supposed to run them above about 80% for more than 10 minutes, and being a Chinese product, you need to reduce that a bit further. So I wanted something that was overrated, so this is almost 200% of the rating that in theory I need, but it should mean that it will allow me to run the power supply for extended periods. But I will be taking the cover off this to have a look at it and make sure that internally it's up to the job. Okay, so it looks fairly reasonable. These are pretty much all the same. I haven't really seen a big difference in quality from one supplier to the next. One thing I will be doing with this is taking this top panel off. Because there's a fan in the main case that we're going to fit the supply into, I don't want this internal fan running inside making more noise. And also I want to get a bit more airflow going around here. Now of course there's always a danger doing this, in that the designers in theory have worked out a careful airflow pattern based on the fan location. But what I'll do as usual is once I've got the thing assembled, when I'm testing it, I'll fit some internal temperature sensors and make sure that it's not overheating. So first thing I'll do is take the cover off this. We'll have a look inside and see if it's going to be reasonable to use this within the supply, and also whether or not it's going to be feasible to run it without the fan and the top plate fitted. Okay, so I've taken the top cover off. I've had a look inside, and it's the expected layout. Quite nicely made really for a cheap device. The main thing I wanted to check was that the capacitors were rated for 60 volts or more. Obviously I don't want to have these running at a voltage where they're going to fail very quickly. Also what I'll probably end up doing is turning the voltage up above 60 volts. That will give me the ability to run the RD6006 up to its full 60 volts, but I will need this to put out more than 60 volts to do that. There doesn't seem to be anything special with regard to the thermal layout of this. I think the fan's just here because it's as good a place as any to put it. And what I'll probably end up doing is, because this is the same size fan as the one that's used in the kit, I shall most likely remove this from this plate and leave it connected to the supply. I believe this is a thermally controlled fan, and I'll fit this to the rear cover of the supply that we're building, and that way we have a thermally controlled fan on the unit without having this secondary fan inside the housing making more noise and probably not really doing that much because it'll just be sort of mashing air around and not achieving much. With the top cover off, the fan should be able to draw air right across the supply. Okay, so that means I won't need to fit the internal temperature controlled fan. I'll see how it goes. I may end up fitting both fans, but we'll see what we have room for. But certainly this doesn't look too bad. I can't see any reason to have to take it apart any further than this. I've checked that the screws holding the clamps onto the heat sinks are tight. This is one thing that's important with these. Sometimes these are loose and it causes them to fail very quickly. But other than that, I can't really see any issues with this. Obviously always check to make sure we're switched to the correct voltage on these. And okay, that looks fine. So next step is to take the top cover off the new enclosure and we'll see how we can lay out the internals. So I've taken the screws out, and in theory we should be able to pop this top cover off. So I've got to say, this has really surprised me. The quality of this is much higher than I was expecting. I was expecting it to be plastic, in all honesty, but this is very nicely made. No sharp edges, very nicely finished. Fits together well. The top and the bottom fit together. If you've ever seen cheap cases, you know that quite often when they're made they just do not fit together properly. But this is just very nice. There's so that even the internals have been deburred, so there are no sharp edges. Even on the cutouts there are no sharp edges, which is extremely nice. So what I'll do is start bolting this together. So we'll see what we've got. I presume there's some feet in here somewhere, so I'll put those on first. So we'll look to see. Yes, in fact we do have some feet. And I'm guessing that, I don't have the instructions for this, so I'm guessing that we have some screws that will attach the feet to these 4 corner holes. So I'll do that first. I've screwed the feet onto the case, so that now sits down nicely on the bench. So the next thing to determine is how the power supply will sit into the base. Also there are mounting holes on the bottom, and hopefully these are the standard spacing, so in theory we should be able to bolt this straight into the case, and indeed they line up perfectly. So we have 2 holes here that line up and 2 down here. So I'll get this bolted in, and then we can look at putting the components on the rear panel. So I've bolted the supply to the chassis, and again the screws fitted perfectly, everything lined up the way it should. Still very impressed. The vent holes are in exactly the right place, so it can draw air in through here, and with any luck this connector will be close enough to the rear panel that we can use the fan that's part of the power supply, and that will save me having to change the connector, because this connector is different from the one that's on the fan in the kit. Okay, so next thing is I'll bolt the main socket and clip the switch in place, and then we can get it wired up. So I've bolted the mains input socket, I've fitted the switch, it all went together extremely nicely. And the next thing is I'll get this wired up to the supply. The required connectors come with the kit. Hopefully these will be the right length. To see which pins are which, of course, you do need the top cover, because it's printed on here as to what the connections are. Otherwise you'll have to trace through the board. So I'll get this wired up, and the next thing I'll do after that is to actually test the supply. Before I go any further, I want to make sure this works before I go to the trouble of hooking it up. And of course I also want to make sure that we don't destroy the RD6006 if there's an issue with this. Okay, so I've wired it up. Obviously the line goes through the power switch. I have buzzed these through to make sure that the crimps are good. Don't just rely on these being properly crimped. Sometimes they're crimped onto the insulation and aren't making good contact. I've checked the earth strap is properly connected, and we'll probably put a second earth wire from here going directly to the chassis. The only modification I've had to make is I've had to bend this corner of the power supply away from the switch. It was a bit closer than I really liked, and it was pushing up against the outer insulation, and at some point that could have worn through. So I've just bent this away. It's all aluminium, so it's very easy to bend, but that just makes it a bit safer. So the next thing I want to do is check that this supply actually works. You can't always guarantee that they will. So doing this the safe way, I have my bench supply turned off so I can connect power without danger of this being live straight away. I'll turn this switch on. We'll get a test meter, and what I can do now is power it up from the bench, and then we can check the supply coming out of this and making sure there's no issues. I'll then do a full pat test on this. I'll do that off camera. It is a bit time consuming, and then as long as that passes, then I can continue with the assembly. So I'll power this up. Hopefully there won't be any flashes and bangs. Okay, so it looks good so far, and now I'll try connecting the test meter to what should be the output of this supply, and we're getting 60.3 volts. As I said, I want this to be above 60 volts so I can get the full 60 volts out of the 6006. So I'll try adjusting this and see how high it will go. I don't want to go too high. I think it will go to about 71 volts, but I don't want to go that high. I've checked, and these, as you can probably see, are 100 volt capacitors, but even so I don't want to put more volts through the output switching devices than I really need to. So that's working. I'll turn it back off, and what I can do now is fit the fan and see if the leads are long enough. And as I said, I would like to reuse the temperature controller on the main power supply. So I'll take the fan off the original internal power supply and see if that will actually fit our case, and if it will, that will be quite a nice solution to have a thermally controlled bench power supply, and we won't need to then fit the internal temperature controller that came with the kit. So I'll just remove this from the panel. And get the supply back in. So this plugs onto the connector inside this power supply, and luckily it does reach quite nicely. So I'll get this bolted in place, and then we'll look at fitting the power supply controller. Okay, so I've fitted the fan into place. Now unfortunately this fan is bigger than the one that came with the kit, so I may have to swap this fan with a smaller version. I can't just use the one that came with the kit and connect it directly to the supply, because this is a 12 volt fan and the one in the kit is a 5 volt fan. But I do have plenty of fans knocking around, so I may just change this particular fan with one that's the right size but is 12 volts. And as I say, I want to do that because I want this to be thermally controlled off the main power supply, not off the controller. The controller itself has its own fan, so if we look on the back of the controller we can see it's got its own fan, so this won't overheat, but I want to make sure that this is kept cool. Okay, so the next thing to do is to use the cables that came with the kit to connect the main controller. Hopefully these will be long enough. If not, I'll have to find some wires. Yes, they're plenty long enough. And they just connect to the little connector that plugs onto the main controller. So I'll get these wired up, and then we can look at fitting the controller into place. Okay, so I've got the main connector wired up. I'm not going to cable tie these, I'm going to just twist them. It's quite a good way of keeping the noise down in the supply. This type of cable does have a tendency to untwist if you want to twist them together like this. So if you want to make them keep their shape, the best thing to do is to twist them and then while you're holding them twisted, just get a hot air gun and heat them up. Don't get them too hot, you'll damage the insulation, but get them hot enough so that you can just feel it starting to go slightly soft, and then hold it under tension and let it cool down, and then it will keep its shape and it will stop it from untwisting again. Okay, so now we've got this far. I have tested this and made sure that I've got this the right way round. It does tell you on the main controller which is which, so we have plus on the right and negative on the left, and you can see that that is indeed the way I've got these wired up, and I have checked to make sure that's what's coming out of the plug. So making sure we have this the right way up, it should just clip into the recess, and hopefully there's enough space between the front panel and the power supply. Which there is, so it should just clip into place. And what we can do now is connect the main supply up. And so in theory, if we now power this up, we should get something on the display. So I'll get it plugged in. Again, I'll turn the switch on the supply we're building into the on position. The bench supply is off. And what I'll do now is turn the bench supply on and see if we get anything on the front panel. So the supply is coming to life. That's a promising sign. The input voltage reads almost exactly what we set it to. We should be able to put it into standby mode, which we can. Okay, the beep is a bit excessively loud. I don't know if that's controllable. If it's not, what I normally do is just put a bit of tape over the beeper. But I want to fit a battery. I think it takes a CR1220. That's for the real-time clock. I need to fit the temperature sensor that came with the kit. So although I won't be using it to control the fan, I will fit this and attach it to the power supply just so that we know what the actual temperature of the supply is and make sure it's not overheating. So I'll do that. That's it as far as building the unit's concerned. What I'll do is just get this finished off, do some testing, and then once I'm happy with this, then in the next video we'll look at using it and see how well it performs. Okay, so I've finished the internal wiring, I've tidied it up. The only thing I would say is missing from the kit are maybe a couple of small cable ties. Not critical, but it would have been a nice touch. It's always nice to tidy up the internal wiring. I've tested this. I've run it for about half an hour under quite a high load just to see where the hot spots are. So I've used the thermal camera to determine the best location for the controller system temperature sensor. So that's now got thermal paste and it's embedded down in between the two DC output devices. So that'll give me the best chance of the system being able to detect an overheat of the system. So what I'll do now is put the top cover on and we'll have a look to see how it appears when it's complete. Okay, that's the supply assembled. It does look very nice, and the quality is not as good as a professionally made unit, but it is very close and would not look out of place on anyone's test bench. I would stress at this point I don't have any affiliation with the manufacturers and suppliers of these. This is just what I'm doing for my own use, and I'm making this video just in case anybody else is interested. But in theory this is now a very high performance power supply. I'll just power it up. And it's still working fine. So this should now give me up to 60 volts at up to 6.1 amps and around 360 watts. So of course that's a very good performance supply. It also has a battery charging, the software that comes with it, and what I'll do in the next video is put it through its paces. We'll give it a good test, see how well it works. We'll test the software, see how well that works, and hopefully it will be a useful addition to the lab.